Hello, can everyone hear me?
Yeah, I can hear.
Okay, yeah, sure. Thank you for coming to the Discord of OpenGuild. We're gonna start in the few minutes. So the students just finished their bootcamp, and I think like they need some time to like switch to this channel. So Okay, to not let everyone like wait more. So I think like we should start now. Hello Joshua, can you hear me?
Yeah, I can hear you.
Yeah. Okay, so yeah, thank you for coming to OpenGuild community, and thank you for like, participating as the guest speaker for our hackathon workshops. So first, I want to introduce a bit about our current Polkadot blockchain hackathon in Vietnam. So the Polkadot blockchain hackathon in Vietnam has five major track: Moonbeam track, or I can say like reward access track, Phala track, um, unit network track for the NFT track, and Bioforce for DeFi, and also turbo development with Apilon. And it's great to have Joshua here as the directors of Tech Evangelist. That's what like I learned from your bio. But yeah, I think like we give the introductions section for you. Could you introduce a bit about yourself and yeah.
Oh yeah, of course. Yeah, thank you for having me. My name is Joshua. I'm the director of tech evangelism over at Phala Network. I've been working here for about 3 years almost now. And essentially, what I do for my day to day is help build out integrations with other protocols, whether it's like Polkadot ecosystem or Ethereum ecosystem or whichever chain that has like any kind of like SDK that we can integrate into our product. I usually build out some like proof of concepts here, and then I also go and teach some workshops, and then do a lot of the developer relations types of task as well. So that's like a brief intro into who I am and what I do over at Follow Network.
Awesome. I think like we have like bunches of question here, but before like we come to that sections, maybe like could you give us maybe like a quote too about like Phala network technology, and also I heard like you mentioned about the demo or something. So maybe like if you have that, like could you share to us as well?
Yeah, is it okay if I share my screen?
Yeah, definitely.
Let's see. All right. Yeah, can you see my screen?
Not yet.
Hmm. Let me check something because it's not letting me right now. Hold on.
Does it work for you, Joshua? Do you need any help?
Uh, yeah, I'm not sure how I can get my screen to share here. It keeps failing for some reason.
Is this because like you don't have the permissions or
Yeah, maybe that's it. Let me uh, system settings. You know which part of the system settings I need to go into to enable the permissions?
yeah, just tag a team to go here and support you because like we're the admin, so like the permission will be granted by us. But yeah, we're checking it now. Joshua, can you try again? I think like our team member just double check your permission, and I think everything is good.
Okay, let me try again. Hmm. Keeps for some reason it's not working. Maybe it's my computer. Me.
Or you can send me the link to the presentation slide or something, and then yeah,
Okay,
then I can help with that.
that can work. I can. But the workshop wise, I want to be able to show the
Mm.
be able to show the workshop and how to build. Um, I think it's something with my settings on my computer. Uh, should be display sharing, screen sharing.
When you share the screen, do you see any option to like update the setting of the live streaming?
Yeah,
Like
it has all
if it's
this.
possible, you like reduce the resolution and also the frame per seconds of the setting.
Okay, I can try that. Oh, yeah, it
Mm.
didn't work. Mm, mm, uh,
Using Discord desktop or Discord on browser, Joshua?
I'm using on desktop, but maybe let me rejoin and see if that can fix it real quick. I'll be right back. Does it work now? Can you see it? Ah,
Try again. Yeah, that screen is my screen. Yeah.
what the- oh, hmm. I don't. It was shown for a second, and then it didn't. Um,
Is it possible for you to try the browser version of Discord?
yeah, I can do that. Let me try this that way. I'll be right back. Okay. Mm. Are you able to see right now?
Okay, yeah, we can just see us right now.
This is, okay. Okay. Yeah, so just here's like some slides I put together um previously for a previous workshop because it's going over the same material, but um I put the title as like AI coprocessor. So the product that we're going to show how to build today is AI agent contract. The AI agent contract is our product to be able to one leverage the ability to create a program that is able to interoperate and connect to different LLM of your choice. So in this case, we'll be connecting to a product called Red Pill, and Red Pill is the ability to be able to have one API key and then connect to multiple LLMs, whether it's like from OpenAI, Anthropic, um, or any of the other like popular LLMs. But I'll go into more details about that a little bit later. So we can look at this like overview is I'll give you like a little quick introduction to Phala, and then the AI agent contract will get started really quickly with the red pill template, and then I'll show you how to transact on chain with the VM SDK template. And one of the things that is like also quite interesting is that with this AI agent contract, since you're developing in TypeScript, you can easily add a package for like the Polkadot SDK, and you could utilize that to be able to interact with parachains directly from the AI agent contract as well. So these are some things that you can do if you're looking to build on Phala. And there's also a template for Apollon. If I remember hearing correctly, Apollon's part of one of the paths that y'all are supporting for the hackathon. You can use the Apollon template as well, and you can also interact with Moonbeam through this VM SDK as well. And I'll show you how to do that whenever we look at the code, and then at the end we can have some like Q&A. Um, so if we kind of look at the architecture, the overall architecture for the AI agent contract, you can think of it from like the simplest explanation is like a fancy little HTTP server. So you're able to one build your program in TypeScript and then next upload it to IPFS, and then from there you serve it through our gateway and make get and post requests to it. So I'll show how this works a little bit later, but this makes it very easy to deploy and then interact with your programs. And at this time right now, these like functions, I guess you could call them, but this AI agent contract is free. You don't need an account. You don't need crypto. You don't need anything to get started. You can get started in minutes, and then you can be interacting with other chains or with other other LLMs, APIs, uh, right out of the box, and then you can start kind of building some proof of concepts very fast. And this is kind of like what we saw at one of our last hackathons, where we were able to get about 10% of the submissions of all the total participants. So this is it's quite a powerful tool and very easy to build on. So when we come to this next part of the AI agent contract, the the best the best quality that Phala Network does provide in this aspect is this confidentiality and secure execution in this case. So Phala Network is a DPIN, which is consisting of well over 40,000 attested trusted like TEE nodes. TEE stands for Trusted Execution Environment. So such that you can execute these programs in a black box. So what we're doing here to show like the execution of the AI agent contract is like in this previous diagram here where we have the upload to IPFS. This off-chain storage is representation of IPFS where your agent script or your agent contract is stored, and then it's served through a gateway and executes within a trusted execution environment. And the reason why this is important is because within this trusted execution environment, these AI agent contracts can also have access to some unique functions. And these functions could, one, say you want to derive a key pair based off of some secret that you stored in connected to your AI agent contract, and that can generate an account for you and then sign and verify messages, but also send transactions on chain as well. So you can do that directly from the AI agent contract, and you're not limited to a certain amount of time of computation. Right now, we put a hard. I think the hard cap is like a minute or 2 minutes, but we can always raise the cap if you need something more intensive. But that's how long of computation execution you have for your request to go through to the agent contract in this case. Um, I'll pause really quick if there's any questions, just to help clarify any things that people may be thinking about.
Yeah, maybe like you can continue, and then like we can have the Q&A sections at the end.
Perfect. So like I mentioned a little bit earlier about the red pill template. So you can think of it here. The red pill API is a LLM router network, and this allows you to connect to like OpenAI, Anthropic, Llama, and all you have to do is change the model that you want to interact with. So if we look here, this is a little graphic I created, but if you scan the QR code, this should take you to the GitHub repo. Um, but the website that you will go to whenever looking at Red Pill, it'll be red-pill.ai. And one of the things here also is if you're looking to build on this template, you can reach out to me personally, and I can give you a code so that you can get $5 of free credit so that you can call the API. But essentially, you'll go to the dashboard. You can log in with OAuth, so you can log in with your Google account. And for instance, I have my account here, and you can kind of see all the different dashboard analytics here. One of the things is you can generate an API key. So for me, right here is the API URL. So this is the URL that I would use to make my HTTP request to, and this is my API key. And these are the this is my usage of my Red Pill API key. So I've used about almost half of my token limit. And if we look at like the details here, this is kind of this is a representation of like a log that you're using. So here I've used, it'll tell you which model you use, the cost in USD, the cost in prompt tokens, the cost in the completion tokens, and the total tokens it took to execute, and then the time that it was executed at. Interesting. Um, so yeah, you can see some of the from my account. If you want to chat with it, then you can go here and chat with it. Um, and you can also choose whichever model, and these are like all the models that we support. I'll go into that a little bit later. But yeah, so that will be whenever you get your account, you can sign up through this, and then you can generate your new API key in this way. So next, I'll go back to the presentation where you can scan this QR code. This QR code will then take us to the GitHub repo, and from here we can start showing how to build an AI agent contract. And this will take it'll be a few minutes just to start. So if we go here, it should be in here. I'll go look for agent red pill, and this should be the repo that you would come to. So you'll see nice little diagram here, and you can see all the steps to get through the tutorial. So we can get started. So I'll clone this here. I'll go into my repo in my terminal, and I'll clone the first template. So this is the red pill template. Great. So now I have this clone. I'll open up one of my IDEs. And then open um, here, go to Phala. Great. So now I have this opened up, and we can kind of uh, follow the instructions. So if we're looking at this here, what are like the benefits for utilizing these AI agent contracts? Well, you can think of it as like a function as a service, and these are edge functions that you can execute. So it allows you to ship fast, build and ship with familiar tool chains, secure. So all this is executing within a trusted execution environment. In this case, Intel SGX. Be able to host API keys, use privacy identifying information for like users in general, and also we have support in this case for this template. It supports Hano, so you can use Hano support here if you know what Hano is, and we use Tiny to like kind of make sure that you don't need to have so much resources allocated. It's just a the minimal amount that you need. And in this case, one thing that is a caveat is we don't have the routing enabled with it, but we can go over that a little bit later. So if we go back here, and we also have the Vite test framework here, so you can write tests in Vite. So you can go to this link and see how to write tests, and you can kind of build test out for your AI agent contract. So let's get started on the initial steps. So I'll open this terminal here, and let me see. Interesting. And then next I'll run install. This should then like install all my dependencies. And you can also use whatever package manager you want. You could use PNPM or um, any other ones that you prefer, like Yarn, whichever. But I'll use like npm.
You zoom in the screen a bit.
Let me see how to.
Okay, yeah, perfect.
Let me see how I'm not sure how to make this zoom in, but I can zoom in here.
Yeah,
Are you able to, okay.
yeah, that's good.
Okay, so we ran the npm install. And the next we want to copy over the environment variable. So the environment variable here, we look here. This is a third web API key. So this is just like a developer API key for you to publish to IPFS, but you can also use like Apollon to publish to IPFS if you'd like, and there's a template for that. But yeah, this is what we're going to be copying over. So see if I can. Can't. I'll do CP here. So now I've copied over my environment variable to the .env file with this command here. And then we already did a little brief overview of the API from Red Pill. So if in a second I'll show how to add your secret in the secret file. But first we'll go and build our agent. So we can do that by running npm run build. So we'll build here, and it's really fast to build, as you can see. So we have it built, and now we can run a test. So if we look in our test folder, we already have like a default API key, but maybe the API key could be out of credits. So let's run a test real quick. I'll zoom in here. So this is like the default API key. That's a developer account. I'm pretty sure it's out of credits right now. So let's just run np run test just so that if you run into any problems, it may, yeah. So as you can see, it'll say insufficient balance as a message here. And that means you've hit your cap on your that means you've hit your cap on your tokens. So if we go back to the red pill, you see this limit here. That means we've hit that limit. So what I'm going to do is use my API key, and if you want to get an API key, we can get you a code. So I'm gonna switch it this here with my API key here, and this is how you can do it for the test in the test area. For the production area, I'll show you how to set secrets there. So we'll do it. We'll run the test again. And you can see it says, who are you for the first test? So who are you for the first test? It says, I am a AI language model developed by OpenAI, and give you some information there. And the next one, it says, what is foobar? And it gives you an explanation of what foobar is, right? One of the things to point out is that on the first query, I used O1-preview model from OpenAI, and the second one I used GPT-4o. But the thing is that we can utilize uh, multiple models. So what if we wanted to use something different than O1-preview? Well, here we can go into the docs, and we can look at the supported models. And these are all the supported models. So we've already done a model from OpenAI. So let's try out Anthropic here. So we can go here. We can replace it in the first test. Do that, and then say maybe try llama for the second one here. And then we can run the test again. So you can see that in the first test, we have like, I'm an AI assistant created by Anthropic to be helpful, harmless, and honest. I don't have any physical body or avatar. So you can see that here. This request to the llama model is taking a bit of time, but that's okay. Um, I just wanted to show you an example. Oh, here it is. Yeah. So you can see all the output from this one. It's a little different on the foobar, but this is like the Llama 2 7B chat. I haven't used that one before, but yeah. So you can see that this passes, but that's how easy it is to add a model. And I'll show you how the structure is. Because so if we look at this first test is a get request. And the way we're able to pass in the model and pass in the query is through URL queries. So if this were like a URL, it'd be like HTTPS colon slash slash the gateway address slash IPFS slash your CID slash and then actually it would be a question mark chat query equals the chat query and model equals model. And that's how you'd be able to define the get request. And then for post, you can just pass it in as a post body. And that's shown here. We'll go into the details of that a little bit later. But now we've been able to run the test successfully and get an output. And this is just showing expected outputs. Now we want to publish our agent. So first we'll do this and run the npm run publish agent. So do this agent, and this should take a little bit of time. And now we have our agent successfully deployed, and we have the address. So this URL here is the address you would make get and post request to. But first, before we do this, we'll need to add secrets. And there's a little description here where your agent requires secrets. Ensure to do the following. It says you need to edit the default.json file or create a new JSON file under the secrets folder. So if we go over here on the left side, we can see secrets here. We can click on that and open that up and see that we have an API key. And this is that default API key that I mentioned previously that is out of credits. So we'll go back to mine and I'll add my API key here. I'll add that here. And since I just edited the default.json file and didn't add a new one, I can just run this command here, npm run set secrets. One other thing here at the bottom, it says deployment information updated in logs latest deployment.json. So though we print it out here for you to access, we also generate a logs file. So this logs file allows you to have the latest deployment that you recently deployed. So it'll give you the CID and it'll give you the URL and the date, date time whenever you published your agent contract. So next we'll run the npm run secrets. So if we're going through the README, we're in this add section secrets area, and we just did this step to add the secret. Now we just need to run npm run set secrets. So I'll run that here. And now I have my secrets added, and then you'll notice that at the end it says log entry added to secrets.log. And we can see that our secret was added here. So we have the CID, the token, and the key, and then the address to access the. So whenever, let's see, let me show you here. So whenever you're making calls to your agent contract, there's this key here. This key allows your contract to be able to access the secrets tied to this key and token, and we can verify the secret by doing this here. So I'll run this real quick just to show you. Run a curl. Let me actually let me just run this in the terminal because it'll be bigger and easier to see. I'll do this. And then you insert your key. So for us, our key is here. And then our token here. I'm going to pipe it into less. And then we can see that this is my API key that I set as a secret to my agent contract. And this is the API key that my agent contract will use. So what I'll do next is pretty simple is I'm just going to go to this address here because it's already printed out in our code. In the code, the default, see, the default chat query is here. It's going to say, who are you? So it's going to default to who are you? I don't have to define it. And it's also going to default to GPT-4o. And this is my published contract. So what I'll do is click here. And you can see, I'll zoom into, you can see the model. And this is just a GET request, right? So GET request using the key. You have the chat query, it says, who are you? And this is the answer. If we want to use a different chat query, I can find an example real quick. Just type it in. So to add a query, a chat query, you just do ampersand chat query equals, and I'll put when did humans land on the, I'll run that. And then now we have a new answer here with the new chat query. When did humans land on the moon? And that's here. And then if we want to define a new model, we just do ampersand model equals, and we'll choose Claude. Give us an answer from Claude. Yep. And this is the answer from Claude here. So that's how easy it is to get it deployed right away and then start interacting with the model. And then if you want, so like the next thing is, yeah, we're sending requests, but how do I test this? And or how do I look at the logs, right? So if we go back here, we go back here, we can see this command here where it says curl. So we'll copy this. I'll put it in terminal instead here. I'll go to my latest deployment, copy this here, and then I'll pipe it into less. And here now, if you're seeing some errors or like something is not working as expected, you can check here and look at your logs to see like what are the calls being made to your oh cool, what are calls being made to your mm, interesting to find what is ESL Pro League in on. Yeah, so you'll be able to see like all the requests sent to your agent contract. But yeah, in short, interesting. But that's how you're able to see like all the requests in the logs. And yeah, so that's like the initial part. If we look at the code um, as well, we can kind of look and see how the get request works. So we go into the get request, we define a vault. This vault is where we stored our secrets. So previously when we set our secrets, this is how we're able to access it. So we parse on the process.environment.secret. This is just how we're passing it through the gateway. And we'll fail if the secrets aren't successfully parsed. API key from the vault here. So if the vault API key field is defined, then we'll access it. If not, we'll go to the default. Then we'll check for queries. So queries here, these are accessed here and defined here. We get the model, default to GPT-4o, get the chat query here. And notice that the queries, they're in an array of strings. So we get the first index of it here. But you can define multiple queries with the same name, and you'll be able to access them through an index of an array. And from there, we get this result here, and then we get the value of the message by calling get chat completion. So if we go here, we look at the chat completion. We're just calling the red pill API chat completions. We're adding the API key here. We're defining the model here and the chat query here, and then sending the request, getting the response, and then returning it back here. And that's the process of the get request. When we're doing the post requests, it's slightly different. You have to it's a little different. You won't be able to access through the browser, but you'll make a curl request for a post request and then define your body similar to like the test in here, where you define the body here and then send that as a post request to your URL body.
Just sure, like we have a few interesting questions.
Mhm.
Yeah, so I already list out some of them. I think like one question would be like how can I think like most of the builders, aside from like building the AI agent, they're also like, interested in building the smart contract. And I wonder like like is this possible? Is this feasible for the smart contract to like make use of the deploy AI agent?
Oh yeah, yeah, definitely. So I can show that with the next template if we have time to show how to do that. Because if we go into Pha's repo here, for the on-chain smart contracts, say you have one deployed on chain, and you want to utilize the AI agent contract, then you can use this agent contract VM, and the VM SDK allows you to interact on chain and do transactions, but also derive key pairs to interact with the on chain smart contract. And I can also post some of the examples from our latest hackathon where teams make some on chain transactions as well. if that's helpful.
Yeah, definitely. And also, like, I wonder what is the maintenance cost of the deploy AI agent over time. Like, I saw like you deploy the AI agent on testnet. I wonder like there is cost anything like over time if you want it to to survive.
Oh, okay. Yeah. So right now, the maintenance cost is it's free, as long as your IPFS file is pinned. So for instance, right now the maintenance cost is 0, but in the future, whenever we come up with like a charging model for these functions, then we will like start charging to keep your contract active in this case. But we're also doing like, for instance, like this is like a one product, like our functions product. Next product is that we're currently about to release a developer friendly version is um, using confidential containers so that you can deploy Docker images on Phala. So that would be like more expansive use case and probably more realistic. But if you want the functions for this case, the maintenance cost in the future will be determined how we define that cost structure. But right now it's minimal.
Yeah, so good. And person, this is a personal question, but like it's not very clear to me like why should we deploy on Phala serverless over the AWS serverless? Because like when I work for my like, other company, like we also have the AI agent, but it's deployed on AWS, and I curious like why should we choose like Phala serverless instead of AWS?
Right now it's cheaper since it's free here. Number two, it's running in decentralized infrastructure along with within a trusted execution environment. So on AWS, you can trust the centralized cloud provider to be able to uh, handle your secrets appropriately and potentially not leak your IP or anything that you deploy there. So that would be like more of the cost benefit is, do you want to run it on decentralized infrastructure or do you want to trust a centralized cloud provider? So that it's just kind of like the trade-off. If you want to use AWS for some like maybe something that this Fallout contract doesn't support, then that's fine. But yeah, pretty much it's right now it's free, it's a low cost, and you get privacy and security by default with the trusted execution environments.
I see. One questions from another audience is like saw on the Phala docs that you guys have the T worker. So with ChatGPT support, how the T rinses that interacting with ChatGPT is secure. I think this one is related to the security aspect and also decentralization.
Yeah,
So
yeah.
you
This is
have
a
to
like a
answer this.
good. Oh, sorry. Yeah. So this is a good question because one thing is the only way that you could, I guess, like make sure that the ChatGPT server that you're interacting with is truly secure is like add another component like TLS notary to be able to also be able to add some more like secure connections to this API in this case. And I'm sure people have maybe heard of like ZK TLS or something like that. Um, adding that, like say like there's a SDK out there that you wanted to use so that you can have a even extra like like a proof to verify that you're actually connecting to that server, and that would be something that you would like add to the agent contract, and that should be pretty, I mean, to me it should be pretty lightweight, so you're just verifying on the AI agent contract end. Right now the connection with the ChatGPT support, either like if you're directly connecting to like OpenAI's SDK, then you're kind of trusting the node that you're interacting with, and the API key that you're supplying to your agent contract is not gonna have some kind of man in the middle attack. If you're using Red Pill, then you're trusting that the T nodes that are connecting to the APIs and being like a relayer to these LLMs are not compromised in this case. So those are uh, some of the security guarantees there that I would say. And another thing is you can also derive a key pair within the agent contract to attest to the output results. So you could sign the message and have that verified within the contract as well.
See. Yeah, hope that answer your question, Fai. Yeah, if you have any questions related to your like to follow up on your previous question, just feel free to leave it here. We have another question is like, why do we need AI agent? And I think this is also the interesting questions that like from the builder aspect, like why they want to build the AI agent in the beginning.
From my perspective, I wouldn't even like focus on the AI part. I would more of like think of it as a agent for like an agent contract that could connect to any Web3 services or, bring in different APIs or external data sources to your on-chain smart contracts. To me, that's what most of the projects that have built on our product has done. Or say that you want to create like that cross of AI and Web3 together to kind of simplify the development uh, efforts whenever you're building a product. So, like in our last hackathon, um, we had about 26 submissions. The first place team, they built a AI agent contract that pretty much was like an anti-cheating implementation to record the user's like hand strokes on a keyboard to detect by connecting to their own specialized model that would detect if they're hitting the right keystrokes and everything, just and then generating a proof to verify that people can verify that they're actually hitting the strokes that the keys that they're hitting, and they're not cheating when they're playing the game. Another one was they built a game where they are going through the game and they're executing swaps, and with those swaps they're able to like verify if they did or not, and if they did then they would submit an attestation on chain. So it's like to me the power of this AI agent contract is really just a secure like general purpose program that can enhance your on-chain application. So in this case, I would more think of it as like an ally to your smart contracts, and you can have all that business logic on chain do what it needs to do, and then you can get very creative off chain with the AI agent contract.
Okay. I think like we ask you another questions, and then if it's possible, maybe like could you like give us a demo of maybe like just a quick skim to like how like my previous question, like how can you like communicate how the smart contract can interact with the AI agent inside the on-chain smart contract, if that is possible. Yeah, and I think there's another question from the audience is like how do you view the potentials of AI agents in building smart contract? So additionally, what are the best practices for like integrating private LLMs with on-chain system for secure and efficient interaction?
So for like the private LLMs for on-chain systems, this is actually something that we just put a paper out. We were able to be the first one to benchmark the GPU TE with the NVIDIA H100. So what we do here is we have the GPU T, and then we have the CPU T that is able to measure the output of the GPU T from NVIDIA. So in this case, you're able to then introduce this confidentiality and secure aspect to the supply chain of building like a private LLM and training your own model. And we did this with Llama 3 as well. So we also have the next paper coming out because with that paper we're able to get access to a H200 and be able to test out their GPU TE. So this stuff is very much in development and like research, and we're working to provide this as like a developer friendly like way to build on this. But right now we don't have it ready. But there's some projects like I think forget what it's I forget what it's called. I think io.net or something like that, where you can use the GPUT model that we have, and for that in the future, that's how we'll be able to um, kind of allow developers to have like a private LLM and also train their own LLMs as well. And
Perfect
then
answer.
yeah, and then the first one it said, "How do you view the potential of AI agents on building smart contracts?" I just see the AI agents really just as like an assistant that kind of build out a unique experience and also allow you to just do things that you can't really do on chain, or it's really really hard to do all of the AI agent implementation on chain. This AI agent contract I feel is more of like a way to just enhance your application and just really get creative and be able to fail fast as well. So that's kind of how I see it. And then you just leave all the business logic on chain that doesn't need to be complicated, and then you utilize the AI agents to do all the complicated stuff and bring something that you can bring like a unique experience for your users in the future for your products.
Gotcha. Yeah, like yeah, he also like have a follow-up question. Is like, what are your thoughts on user OAI, or I can say like self-hosted AI?
Uh, oh yeah, so that's kind of like the whole like the inspiration of our GP like our investigation into GPT, because we were thinking that since all these centralized providers, all these big companies, they're going to be owning all the LLMs that we interact with every day, and there's a supply chain that allows us that kind of prevents us from cracking into that. So we thought that we needed to break down this supply chain by introducing some security and confidentiality into the supply chain of these LLMs, so that one, we can have some verifiability as well. So that's where the TEs come into place. Because if you do it through like ZK or FHE or MPC, it's just way too expensive to even think about having like having an LLM run on that technology. So the only solution right now is utilizing a TE to introduce that verifiability, and with that verifiability, we can then start to think about, oh, how do we allow users to contribute their personal data, or say businesses contribute their private data, but also do it in a secure and privacy preserving way. That's how we are able to. That's how we are thinking about like the GPUT and utilizing that confidentiality by default. Um, with the TEs in general, such that we can potentially create some kind of verifiable way to reward users and also have an LLM that's trained on user provided data.
Okay.
Yeah. Yeah. If you listen to our CTO or CEO, Marvin or Hong, they have like a lot of material out there talking about this. It is a very interesting area to think about, because it gets quite yeah, it's an interesting concept to think about.
Gotcha. Okay. So I think like because it's run out of time right now, even though like we have a lot of interesting question, because like AI is a very interesting topic that like most community member like would love to build the application on it. Um because like we run out of time. So I just wonder like if it's possible for you just quick skim through some materials so that like they can learn more about like how can do the smart contract and AI interactions, and then
Let's-
we can wrap up our workshop today. Yeah.
Yeah, so if I went pretty quick, but if you go to our docs, just go to this VM page to build an agent to transact on chain. And this will take you through the steps here. And then also I made a video. Where's the video at? Oh, there's a, well, like on this page, there's supposed to be a video here. I don't know why it's not loading, but um, let's see if yeah, so I guess I can show you this example. These are some of this is the agent I deployed. Um, see, so here this is I deployed this a while back, but it derives a key pair here. So now you have like a ECDSA account here. So this is the public key that's derived. Then I can sign with that. So now I can see that I have some data signed by a TE, and this is a signature, but then I want to verify it. So I verify that signature. This one's false because I need to update the docs, but the signature should be, go back, go here. We see that the signature's here. Get that. And then if I want to verify, I'll go to verify data signed by TB and signature equals, yeah. And then you can see like you can verify the signature is this data. See, and this is like sending it on base, but this is just sending a transaction. I don't have a gas in there, but if let's see from this, but you can think of like, though this is on base, you can think of it as why not do it for like Moonbase in general. So if I go to, this will be like just more of like sending a transaction, or not like sending a crypto, but it directly translates to sending or interacting with like a smart contract. So like if you use the VM SDK, yeah, so this is a successful transaction now. So with the derived key pair within the AI agent contract, we can go to base scan. But you if you're using like Moonbeam, so for the hackathon, just oh, that's the, where's the function? Nope. Base, yeah, so we can see the transaction here that I just ran 41 seconds ago. So you can see that. But if you're using the VM SDK, vm.sh, I'll just do this really quick. Go into the docs, chains, implementations, chains, configuration.
Wait, so Vim is on Ethereum Solidity smart contract, right? I wonder like
Yeah.
if like can you interact like to like ink or something like Polkadot.js or something?
Oh yeah, yeah.
Yeah.
If you use their SDK, you can easily just import. So like in your code, you just go into the package.json file and just add the package here in the dependencies, so that you could use like Polkadot SDK if you're interacting with a parachain, if you're interacting with EVM chains or ones that have EVM precompiles like Astar. So you could connect through VM in that sense. And I think also forgot what it's called, Akala is also on that too as well. But yeah, you can easily add it here, and then you have that SDK out of the box. So we don't our goal was to make the developer experience very easy and not have to rewrite a bunch of code or have to write our own version of their SDK. It's just their SDK works out of the box, and then you get to building with just like a secure interface to your on-chain applications.
Awesome. Yeah, really like project that have like good developer experience. All right.
Mm.
Uh, so I think like that's also the wrap up of our community call today. No, like our workshop today. And it's already like more than an hour, and you really like dedicated with the workshop and your presentation, also like your demo, and that would be like our honor to have you here, Joshua. And thank you for coming to our workshop.
Of course. Yeah, thank you very much. And if oh yeah, just to add another thing is we have a lang chain template as well. I created a lang chain template that you can use. Um, yeah, it's a pleasure talking to you all. If you have any questions, don't hesitate to reach out. And if you want to play with our Docker containers that we'll have ready in the next week, I'll send that out to y'all as well and create like I'm gonna create a video as well for that. So just let me know if you have any questions, and I'm happy to help.
Yeah, definitely. So if you have any material or like any like new release on like the Phala technology, like feel free, just pump into our OpenGuild Discord, and definitely like our like bootcampers or like our hackathon builders, we're definitely really interested in those material for their progress of building application on Phala.
Of course.
Okay, and yeah, that's also the wrap up of our workshop today. And thank you everyone for listening to the presentation of Joshua. And please give like a big applause to our guest speaker. And I hope that we can have the future workshop with Joshua as well to learn about like AI and also like Phala Network.
Thank you, everybody. Have a good day.
Thank you everyone. Have a good day.